In this lesson, we're going to talk about solving quadratics by the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the values for a, b, and c come from a quadratic that is in standard form. So recall ax squared plus bx plus c is standard form. So that's where the a, b, and c will come from for that quadratic formula. We're actually not going to be solving any quadratics today. We're actually going to just be talking about the portion of the quadratic formula that's inside the radical, and that is called the discriminant. So the discriminant is that b squared minus 4ac. The discriminant can tell us about the types of solutions that we will find when solving a quadratic. So if the value of your discriminant is a positive number, so that means that it's greater than 0. If you work out the discriminant, b squared minus 4ac, and you get a positive value, then that means for the number of solutions and the type of solutions, that you will have two real solutions. So you would solve the quadratic, which we will not do yet. We're just going to talk about the discriminant, but you could continue solving and find those two real solutions with the quadratic formula. If the value of the discriminant equals 0, then that means we have one real solution. And then finally, if the value of the discriminant, remember we're talking about this b squared minus 4ac, if that value comes out to be negative, then that means it's less than 0. We would have two non-real, which is those imaginary solutions. So we will actually not be finding any of these solutions in this video. We're just going to be focusing on the discriminant and talking about the value and what it means for the solutions. Let's relate that to some graphs. So let's first talk about if I had this graph of a quadratic, and it does not matter if it opens up or opens down. So here if I had one that's opening up, maybe crossing the x-axis in two places, or even possibly having a quadratic that opens down, again crossing the x-axis is two places, that would mean that it has two real solutions. And that is because you have two x-intercepts. So this would mean that we have a positive discriminant. Actually, rather than writing out discriminant, I'm just going to write the formula, b squared minus 4ac. So anytime you have a graph of your quadratic and you cross that x-axis two places, again, it doesn't matter if it opens up or opens down, then that would mean that you have two real solutions because of those two x-intercepts. So let's talk about maybe a graph that just touches the x-axis in one place. So again, it doesn't matter if it opens up or opens down. So here if I have a graph here, the vertex is on the x-axis, or even here, the vertex is on the x-axis, that one spot that it crosses the x-axis means that it has one real solution because it has one x-intercept. If it has one real solution, then that means the discriminant equals 0. So finally, to see a graph that does not cross the x-axis, so maybe it's opening up and it just never touches that x-axis, or even could open down and never touches that x-axis, that would mean it has two non-real solutions. And that's because there's no x-intercepts. You would have two non-real solutions. They'd have to touch that axes in order to have real solutions. So that would mean that the value of your discriminant would be a negative. So let's do some actual calculations with the discriminant formula. Example number 1. We're going to start with negative 4x equals x squared plus 1. Well, before we can ever get started, remember, in order to calculate the discriminant, we need our b squared minus 4ac. We need to get our equation set equal to 0 and written in correct standard form. It's my preference to keep my a positive. It's not necessary when doing this. It's just my preference. So I'm going to add the 4x. So this side cancels, leaving us with 0. This is 1x squared. I'm going to go ahead and put the 4x next because it's my bx term, and then plus 1 for our c. So to find the discriminant, we'll use b squared minus 4ac. So of course I need my a, b, and c values. A equals 1, b equals 4, and c equals 1. So plug those into the formula. B squared minus 4ac. And notice, because I have all positive, it wasn't necessary, but I went ahead and put parentheses around every number that I was plugging in. Because it is going to matter, especially here when I'm squaring a negative, I have to have parentheses. So let's work this out. B squared minus 4ac. You could do order of operation with that, but I'm going to let the calculator handle it. So 4 squared minus 4 times 1 times 1. Turn it on. Try again. 4 squared minus 4 times 1 times 1. There, we get a value that equals 12. So go back and look. If our value of the discriminant was positive, it came out to be greater than 0. That means that we have two real solutions. We do not know what the solutions are until we solve the entire quadratic formula. But if you solve this with the quadratic formula, you would come up with two real solutions. Let's go ahead and look at example number 2. Here we're going to have 15 plus 2x squared minus 6x equals to 0. So this problem's already set equal to 0. However, we notice that it's not set up in standard form. We need our ax squared, then our bx, and finally our c. So let's reorder these terms. 2x squared is first, then the minus stays with our 6x for our bx term, and then finally that's a positive 10, so plus 15 at the end. So now we're ready to name our a, b, and c so that we can put them in our discriminant formula. A is 2, b is negative 6, and c is 15. So we plug those into the b squared minus 4ac to find the value of the discriminant. So b squared minus 4 times a times c, carefully plugging each value in the correct spot into the formula. B squared minus 4 times a times c. So when we work that out, again, you could work order of operation, or when we type in the calculator, negative 6 squared minus 4 times 2 times 15. And notice I've typed it in exactly how I have written it on my paper, including the parentheses, so that the calculator knows exactly what I want it to do. So I have negative 84 for the value of our discriminant. So if that value comes out to be negative, we will have two non-real solutions. Again, we have not solved for these solutions. If you were to solve this equation with the quadratic formula, you would actually find those solutions. This discriminant just tells us what type of solutions we would find. Let's look at one last example. Number 3. Here we have x squared minus 2x plus 6 is set equal to 4x minus 3. So notice the left-hand side looks like standard form. However, this is not set equal to 0. So we cannot start with naming our a, b, and c until it's set equal to 0. So let's subtract 4x, lining it up with its like term, and add 3, again lining up with its like term. So we have x squared minus 6x plus 9 for our standard form. And of course that is now set equal to 0 because those terms all cancel. We find that our a equals 1, b equals negative 6, and c equals 9. So our discriminant formula, b squared minus 4ac, negative 6 squared minus 4 times 1 times 9. When we calculate that value, negative 6 squared minus 4 times 1 times 9. And I've got too many parentheses there. There we go. B squared minus 4 times A times C gave us a value of 0. Be careful with this one. Some students want to say that there's 0 real solutions, and that's not true. If your value equals 0, you have one real solution. Just think back to what that means for the graph. It would hit the x-axis in one place. So this means that we have one real solution. In the next video, we will learn how to actually solve using the quadratic formula.